Hello everybody, welcome to the course Data Structures. This is a series of lectures introducing students to the basic data structures, and also we'll look at the code implementations of the basic data structures throughout this series of lectures. So So this course, the course outline, introduction to data structures. So we'll be looking at some of the fundamental data structures and why data structures is actually important for a graduate course. And also we'll look at the abstract data types. Basically, throughout this course, we'll be using Java as an implementation tool. We'll be looking at the ADTs of Java. And followed by we'll be looking at some of the linear data structures like stacks, queues, linked lists and vectors, and some of the non-linear data structures like trees, graphs and etc. The motivation behind doing this course is to give a complete outline for a student to the basic data structures, not just the theory but also some hands-on on some basic codes which a student can play around. The textbooks and references that I'm going to stick are Goodrich textbook, the Roberto Tamasia textbook, 6th edition. The title is Data Structures and Algorithms in Java. And also, Corman can be used, but I primarily stick to the first textbook. And as part of this series of lectures, we'll be going through a lot of application-oriented questions. I really find Geeks for Geeks is one of the best site to learn different kinds of questions on data structures because I feel data structures is actually like an ocean with a lot of questions that can keep coming, and people will be building a lot of solutions. So I find Geeks for Geeks as a best platform where people are actually discussing different kinds of solutions for different problems. I often visit that site. So I request also the viewers to go through this site. And by the way, I'm not just advertising about the Geeks for Geeks, but I find it really useful. So I'm just recommending it to you people. And a lot of reputed university materials I'll be using, and also the problems. As I said, this is not just a theory course, but I really want people to get in to the actual problem solving. So like I said, the implementation of data structures will be based on Java. Um, I can understand few people wants to do it in Python, but currently for this set of lectures, I just stick to Java. The software requirement will be you need a Java 7, and then Eclipse or NetBeans IDE will do, and text editors like Notepad++, Sublime or Visual Studio Code will do good to write your codes. So, kickstarting my course with the first lecture. So, what is basically a data structure? In simpler terms, it is a structure of the data. Some general operations generally that we want to do if I have data are something like I want to insert something, I want to delete some particular data, I may have to search for some data, I may do a sorting or modification or different operations. So I just gave a wiki definition of what is data structure. This is a pure formal definition. So in computer science, a data structure is a data organization, management and storage format that enables efficient access and modification. So more precisely, a data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to the data. So basically, a data structure is nothing but how the data is being organized so that a user can efficiently access that particular data. This is all what we are going to see throughout this course. We will be looking into multiple different kinds of data structures and different applications where these data structures can be applied. and how the choosing a particular data structure for an application will impact on the running time. That means the response time. I can also call it as a response time of how we are accessing that particular data. So why data structures? Because we have a huge volumes and volumes of data being generated daily in different formats. So we need some kind of a organized way to arrange all this data such that all my processing techniques can be applied easier. So organizing data is important for effective retrieval, because after all we are arranging all the data in some organized fashion so that my retrieval process will become easier. So like I said, the organization of data is nothing but choosing the right data structure so that I can model my data using this data structure and put it in some format so that my retrieval process, or for that matter any kind of a processing on the data, will become easier. So choosing the right data structure will be depending on the application that we are choosing. So the basic philosophy of data structure is the data is growing exponentially day by day and applications are becoming more complex. That means that as the data is growing and the applications are becoming more complex, we need better retrieval techniques that reduces the response time. So for those people who doesn't know what is response time, so response time can be something like you ask a question to a particular system and how much time the system is taking to give you an answer. So to better understand, I can say something like, okay, I have asked Google Assistant a question like what is the height of Eiffel Tower. Let's say the Google Assistant is taking a long time to answer the same, which is not an acceptable situation for a user. So we as a user, we want the response to be very quick. So how the response is being generated and how we are reducing the response time will be depending on what kind of a data structure we are using and what kind of retrieval techniques we are using to retrieve the necessary answers. So data structure chosen for an application directly impacts the response time. So given a particular problem, the task is to find a solution. So given a problem A, I can have multiple solutions. For suppose, take an example of Google Maps, where a person wants to travel from Hyderabad to Bangalore, or maybe you can take something like a person wants to travel from Coimbatore to Bangalore. So there is a possibility that the person can travel in multiple routes. So the source is Coimbatore and destination is Bangalore, and the person can reach from Coimbatore to Bangalore in multiple different paths. So which path has to be taken such a way that the user can actually reach Bangalore faster? So given any kind of a problem, there may be multiple solutions. So all are solutions which are leading to the actual destination, but choosing the better ones is what we are looking for. So choosing the most optimized solutions out of all the available solutions is the goal of this course. So which is a better solution? So we say that, okay, a particular solution is an optimized solution. So how are we categorizing that this solution is actually a optimized solution? So for that, we are taking two parameters called time and space. So we are analyzing a particular algorithm based on the time as well as the space. That means that given an algorithm, and the algorithm is actually giving me a solution, we are trying to analyze how much time the algorithm is going to take to run, and also how much memory the algorithm is actually consuming to give me a solution. So based on these two parameters like time and space, we are defining efficiency of the algorithm. So the Efficiency can be calculated by doing a complexity analysis, which includes counting primitive operations. So this is nothing but analyzing an algorithm step by step and trying to find which step will take how much time is what is done in complexity analysis. So in the next set of lectures, we'll go through the complexity analysis. Thank you.